Question is two lamps have resistance R and the capital R being greater than R. So here capital R is greater than small r. Okay. If they are connected in parallel in electric circuit, then so we are connected in parallel. Okay, this, okay. Basically, what we are doing, this is again good question. So basically, we are connecting parallel wires, parallel lamps. We are connecting parallel lamps. Resistance R and capital R. So see, this is R, and this is capital R. You are connected in parallel. We are connected in parallel. Okay. So the lamp with the resistance R will shine more brightly. So if you see in parallel, voltage is what? Same. Voltage is going to be same in parallel. Okay. So basically, if you see, power will goes to what? V square by R, inversely of R. Yes or no? If the resistance is less. Okay, power will be more. Do you agree? So, go through all the options. Read one by one. So lamp with resistance R will shine more brightly. Okay, why? Why? Because R value of R is less. The value of R is less. Okay, two lamps. R is being greater, so R is less. So because R is less, okay, so definitely power of R will be more. So lamp with R will shine more brightly. Next is the two lamps will shine equal. This is wrong. Two lamps will resistance R will shine. This is wrong. The lamp will resistance R will shine more brightly. The lamp with resistance, this is again wrong. So basically, what in parallel connections is parallel. So basically, you need to take care that voltage is same in across both the load. So if the resistance, so compare with the resistance. So you can go through these options. So correct answer will be two. So moving for next questions. Next questions in front of us. That is, two bulbs are fitted in a room in the domestic electric installations. If one of them glows brighter than the other. You see, here question is very good questions. Question is that okay, we are talking about domestic. Okay, we are talking about domestic. Okay. So two bulbs fitted in a room in a domestic electric circuit. So you should know the basics of domestic electric circuits. So when we are talking about domestic electric circuits, all the domestic circuits are done in parallel. Okay, so this is the concept only in these questions. So if you know this questions concept, you can do this question now. So now you connect this through the wire. And so brighter will have a smaller resistance and the so now this question become very easy. So I am leaving these questions on you. So tell me everyone what is the answer for these questions. Okay, go through all the options. The brighter bulb has a smaller resistance. Again, the questions will be similar to the earlier questions. So we can go through these questions again. Comparatively, like earlier question, we have completed last question. So now we're moving for next questions. So this is, I'm showing you here three identical bulbs P, Q, and R are connected to a battery as shown in the figure. So when the circuit is closed, now we are closing the circuit. Okay, so when we close the circuit, okay, so what will happen? Okay, current will start passing. Yes or no? So again, options are in front of you. Okay, so see here, three identical bulbs, three two bulbs. So Q and R, bulb Q and bulb R is connected parallel. Okay, and bulb P is connected in series. Yes or no? So again, this is very good question. This is very good question. So. So here P is connected. P is connected. Three. This is identical. All the bulbs are identical. Yes or no? So take care of all this thing. Means if this is suppose I'm taking capital R for understanding point of view. This is capital R. This is capital R. This is capital R. So this is connected in parallel. Okay. So if this is connected parallel, so you could take equivalent of this. So this equivalent will be like this what? R by 2. This become R by 2, but this is only R only. Okay, this is R only. Okay, so this is not going to change. And again, this is connected to the battery. And if you see the concept says what? Okay, this is R, capital R, this R by 2, connected in series. So in series, you need to take care of what? You need to take care of what? Tell me. You need to take care of current. So if I will tell you in series, P is what? I square R. Okay, P is what? I square R. If you know, you know. If you don't know, you don't know. Okay. Now you can go through all options and you can correct the answers. Okay, so what answer is coming? Q and R will be dimmer than P. Q and R will be dimmer than P. Okay, so means whose brightness will be higher. Okay, the brightness of P will be higher. So I hope you understood the logic. Here, basically, we are doing power is proportional to R. So the bulb who have more resistance, they have more power and all. And all. You will go on this thinking. Okay, so it's a series of matrix of thinking. You will go think. Thinking goes on, then definitely you will do all the questions correctly in your examinations. If you know the concepts, you know. If you don't know, So please don't attempt the questions. It will demotivate you to do the questions. Okay, so if you know, then only attempt all these questions. Yeah. So next questions in front of us. This figure shows three similar lamps, L1, L2, and L3 again, and this is connected across the cell, this. So if the lamp L3 fuse, okay, so basically what's happening here, L3 lamp is fused, L3 lamp is fused. So the light emitted by L1 and L2 will change as. See, what will happen if L3 will fuse, if L3 will fuse, so resistance of L2 will increase, yes or no? Resistance of L2 will increase. So you apply this concept. I'm leaving options on you, then go through the correct answers and select the correct answers. So this, and this. So correct answer will be brilliance of L1 decrease and that of L2 increase. Okay. So obviously, if L2 will increase, okay, so brilliance of L1 will decrease. So again, this is again good question. So you can go on matrix of thinking and goes on. Next, again, we are moving for next question. If you know, you know, you don't know, you don't know. Okay. Yeah. Next, we are moving for next questions in front of you. The potential difference across the conductor is developing the rate of degeneration of heat. See, I don't know this question. If you know, you know, I don't know. This question is very easy. So basically, what we are playing with potential. If you know the potential and rate of heat generation and all this, then you can do all this question in the seconds. If you don't know, you don't know. You don't know, you don't know. You don't know, you don't know. You know, you know, you don't know, you don't know. Leave it. Okay. Moving for next question. So this are two metallic wires. So basically, what's happening in these questions? I have to go through like this. Yeah. So two metallic wire of same material, okay, and same length have different diameters. Okay, so basically diameter D1, suppose this is diameter D2, and all other parameters are same. When the wires are connected in parallel across an ideal battery, the rate of the production in thinner wire is Q1. Thinner means okay, what? Thinner means what? Who have suppose D1 is less than D2. I'm taking like this. Okay, suppose D1 is less than this D2. So this is what basically thinner. Okay, this is thinner. D1 is like that. So rate of heat generate produced in thinner wire is Q1 and that is thicker. This is thicker, so here is Q2. Wires are connected in parallel. Okay. So basically what we are doing, we are connecting the wires in parallel. Okay, okay, okay. So if you're connecting the wire in parallel, if you're connecting the wire in the parallel, this. So basically, see, you want to again play, we have to play again with the resistance. Resistance, basically, you should know the basics of R is what? Rho L by A. Rho L by A. Two metallic wires, same material, same length, and different diameters. Okay. So length is not going to participate over here. So here, play with area. So if D1 is less, so A1 will be less. Okay, simply think like this. A1 will be less than A2. If A1 is less than A2, so you can say that because A1 is in denominator, so again reverse, take reverse over here. So you have to know all the concepts, then only you can attempt such questions, otherwise leave it. Okay, R1 is greater than R2. Again. This is parallel combination. So parallel combination, I already said power, this heat produced in the same load. So in it, heavy heat produced inversely proportional to resistance. So again, if you know, you know, you don't know, you don't know. Okay, so then this way you can go through the options. So correct answer will be in front of you. But so inverse, so R1 is greater than R2, R1 is greater than R2, so this will be less than. So you can go through all the options. I already explained all the concepts. If you know, you know. If you don't know, so think why you don't know all these concepts. Okay, and I'm moving for next questions. Yeah, the next questions I have in front of you. There are two metallic wires of same materials and this again, this like this. Focus on the questions, two metallic wires. Same material means row is same length, but of different radius. So again, I'm using R1 and R2. Okay, they are connected in ideal battery in series. So connected in series. No issue in it. Okay, and it produces actual connected in parallel, and then when this will for the same time. Okay, so when they are connected in ideal battery in series, heat produce. Okay, so when we are connecting in series, so heat produces actual. No issue in it. Okay. And when connected in parallel, so when we are connected, so I am just changing something like this. Okay. So when we are connecting, when the connecting in what parallel, so then it produces what H2. No issue with it. Okay. So you can go through it. So this is H2 and this is H1. So basically, again, you have to play with resistance. If you see this is series combination resistance is going to be what? This different radii. Again, see radius. So I'm taking suppose R1 is less than R2. So again you have to play with all these things. So basically I'm just assuming this resistance is R1, this resistance is R2. If you take series combinations, R equivalent over R1 plus R2. And if you take parallel combinations, R equivalent is going to be this one. 1 by R equivalent is what? R1, R2 by R1 plus R2. R1, R2 by R1 plus R2. Basically, in parallel combination, R equivalent is going to be less. Going to be less with both R1, either R1 or either R2. Okay, think like this. If you know this concept, you can do these questions. Otherwise, you can't do these questions. I'm giving you options and I'm giving you the answer key over here. So this. So actual will be less than H2. Okay, actual will be less than H2. H1 will be less than H2. Okay. So basically, what we look at, so you basically I'm using the concept. So what you can think like this. Okay, think like this. Think like this. Okay, B square power is what? B square bar. Think like this. Okay, play with B. Okay, and play with R. So when your questions comes, first go with voltage. Or I'm giving you trick. This trick is given by me only. So what I'm saying, just okay, just kidding. Okay, so this trick. Okay, always go through the trick. Whenever you need to compare, just follow the voltage. Okay. And if you can't compare with voltage, then go for current. Okay. Yeah. So I'm moving for next question. Correct answer is here. H1 is less than S2. I had discussed so many questions based on this concept. So this concept is very important for okay. If you are okay targeting good ranks, definitely this concept will help you. Next question we are moving to electrical. This the P1 watt, V volt, P2 watt, V volts are connected in series across V volt. Supply the total power consumed is. So question is asking very good question. This concept is very good questions for rank point of view. So see question two electric bulbs rated P1 watt and V volt, P2 watt and V volt. So this is basically what P1 watt, V volt, P2 watt, V volt connected in series across V volt supply the total power. So see, you know the relation, you know the relation, you don't know the relation, you don't know the relation. So what is the answer? Please tell me. What is the answer? So basically what I'm telling, just I'm giving you two tricks here. If you know these tricks, you can do all this question in seconds. So when I'm talking about series, in series, okay, power is what? 1 by P equivalent is 1 by P1 plus 1 by P2. 1 by P1 plus 1 by P2, 1 by P1 plus 1 by P2. And when we're talking about parallel, when we're talking about parallel combination, P equivalent is what? P1 plus P2. If you know, you know, you don't know, you don't know. So I will explain you. So you're gonna have to take help for these illustrations. So I explained the concept. So answer going to be third. Okay. So I'm moving on now. Moving for next questions. Journey is so long. Yeah. Moving for next question. About questions in the first again, same question I already explained you. So please answer this question partially. Next, we are moving for next questions. Okay. So Kirchhoff's law of masses in accordance with the law. I don't know this question. I don't know. I don't know this question. Seriously, please answer this question. So this is Kirchhoff's law of masses. When we're talking about mass, see, don't just jump and I know this question and don't go Kirchhoff's law and just jump on question. Not at all. Here I'm talking about mass. Here I'm talking about masses. Mass. Okay, so we are talking about masses. Okay. Next questions. I'm going for next questions. If you know, you know, you don't know, no, don't know. Okay, yeah. Next, Kirchhoff's law of junctions is also called the law of conservation of again good question, again good question, again good questions, again good questions. Answer the charge. Okay. When we are talking about junctions in junctions, so basically what we do, summation of currents, you know, you don't know, you don't know. Okay, so I'm moving for next question. So answer is charge. Next questions in front of us is yes. Wheatstone region is most sensitive when the arms are again very good question. Ranker question. If you know, you know, you don't know, you don't know. Yeah. So when stone bridge is most sensitive, then their arm ratio is okay. Wheatstone means I'm saying stone. Okay. So Wheatstone, okay, bridge is most sensitive. So basically, question is talking about its sensitivity is high, then arm ratio. So arm ratio is what? Arm ratio is equals to 1. So if you know, you know, you don't know, you don't know. So I'm going for next questions. Yeah. In galvanometer battery and interchange balance, we just is done. So basically, what we are doing, we are changing galvanometer and battery and interchanging. So we just raise then. Battery discharges the bridge, still balances the balance point is this. Again, a very good question. If you know, you know, you don't know, you don't know. The bridge still balances. Okay, bridge will again still balances. So bridge will be balances. Okay, bridge will balances. So take it. This is very again good questions. If you know, you know, you don't know, you don't know. So galvanometer, we are still changing galvanometer and battery. If you know, you know. If you don't know, you don't know. Yeah. So I'm moving for next question. I'm moving for next question. If you know, you know, you don't know, you don't know. Next question is this is last one, and this is this. Again, good question. Again, good question. You know, you know, you don't know, you don't know, you don't know, you don't know. So I'm giving you first options. And so what is your answer? Final answer is second. So final answer is second. Ohm's law is what B equals to IR and Joule's law is what I squared RT. And Kirchhoff's law is what? Kirchhoff's law is what? Junction's law? Junction's law? Then what about Kirchhoff's second law? What about Kirchhoff's second law? Kirchhoff's second law is all about loop law. So again, if you know, you know, you don't know, you don't know. So we're moving for next questions, next concepts, next. See the intelligence. See next questions, your intelligence. Meter intelligence. Okay, what is your level? Next questions in meter range experiment, the known and unknown resistance in the get to gap are interchanged. The error so removed is basically what we are doing. In meter bridge experiment, what I am doing, known and unknown resistance into gaps. This is known and this is known and this is unknown. Okay, this is unknown. Okay, this is known and this is unknown. So I'm interchanging it. So what will happen? So the error so removed is error so removed. Again, this is a very good question, but simple question. Anyone can do this question if you know, if you have gone through all the things in your life, then we can do. So the answer is error so removed is and correction. So by doing this, we can remove the and correction error. Yeah. So again, if you know, you know, you don't know, you don't know. Okay. Next question. We are moving for next questions. We have in a meter wire structure in the left. See, in a meter a metal wire is connected in the left gap, external resistance is connected in the right gap. You know, I think you know meter base. You don't know. You don't know, leave it. This is not for you. If you don't know, please, okay, don't go through it. Okay. So yeah, in a meter base, metal wire is connected in the left gap and external resistance is connected in the right gap. No issue in it. Balance point, we go to balance point, no issue in it. If the metal wire in the left gap is heated. So basically what we are doing, metal wire in left wire is, I'm trying to heat it. I'm putting some amount of heat, so balance point will hurt. Balance point will be what? Okay. See, again, this is very easy questions. You can do it. Think, but it's an intelligence question. If you know, you know, you know, you don't know, you don't know. So if you don't know, then don't try to attempt this question. Yeah, otherwise it will demotivate you. So what's the answer? So shift towards right, shift towards right. So I'm not going to explain what's happening over here. Just use your brain, use your sense. Basically, what's happening on increasing, on giving heat, what's happening? Resistance. Resistance is increasing. So if your resistance is increasing, you need more length. So I think this concept is enough for this time. Okay, so I'm moving for next question again. Next question we have. Series high resistance is preferable than shunt resistance in the galvanometer circuit. Series high resistance is preferable than shunt resistance in the galvanometer circuit of meter bridge or potentiometer because why? Why? So this question is again brilliant question. If you know, you know, you don't know, you don't know. So series high resistance is preferable than shunt resistance in galvanometer. Okay. So I hope all of you know about the concept of what is all about shunt. If you don't know shunt and what's all these things, so please I will tell you this is not for you. So please don't go on these questions. Okay. Yeah. So shunt resistance are fine. Nothing nonsense. So what's the answer? Answer is series resistance reduces the current to the galvanometer in an unbalanced meter bridge. Okay. So if we put some series high resistance, it reduces the current. To the galvanometer in an unbalanced meter bridge. Okay. So I think you know and all. We are moving for next question. See this question. Don't be fed up with these questions. Okay. Don't get scared with these questions. If you know, you know. You don't know, you don't know. So don't try to attempt these questions if you don't know. Okay. So this is questions. The metal wire is connected in the left gap. Semiconductor is connected in the right gap. Okay, of meter bridge and balancing point is found. Okay, basically in this left side we are taking metal, no issue in it. In the right side we are taking semiconductor, no issue in it. Yeah, this is semiconductor. Okay, right. So both are heated, so the change of resistance in them are same. So basically, see, I'm telling you the concepts. If you don't know, don't mind. Okay, I'm going to explain it. Okay, see, if we heat metal, there the temperature resistance will what? The resistance will what? Can I say resistance will increase? And for semiconductor, can I say resistance will reduce? Tell me, everyone. So there will be one point where both resistance will be increased. So yes or no? There both resistance will be same. Okay. Then the question is talking about balancing point. Question talking about balancing point. To see where resistance is more, you need more length. Yes or no? So you need more length, and so correct answer is shift towards right again. Shift towards right again. Okay. We are moving for next question. I think you know. If you know, you know, you don't know, you don't know. Don't mind me. Okay, next questions. Yeah. So metal wires connected in the left gaps. I'm going this question. Okay, little bit frequently because I hope you understood. Also, metal wires connected in the left hand to germanium connected in the right gap. So we this is germanium. So this is what can I say? This is semiconductor. Can I say? You don't mind? Can I say? Okay. So this the balancing point is found to be 50 centimeter. Metal wire is heated. We are heating metal wire and germanium is cooled. So yo. So see, basically, if you heat metal wire, resistance will what increase. If you cool germanium, so what will happen? What will happen? Again, resistance will increase. Again, resistance will increase. Yes or no? So that variations of resistance in them are equal. But variations changes means delta of R is same. So here, whatever is delta R, this side also delta R is same. So both sides, this is very dense, and then the balancing point. Again, this is very good questions. This is again ranker questions. If you know, you know. You don't know, you don't know. So okay, take risk and tell me your answers. So we'll note it because I already explained all the concepts here. Okay, left side, right side, whatever. Now we are moving for next question. Next question we have. So in a meter with experiment, okay, and the resistance in the gaps are interchanged, then the balance point did not sit at all. So I don't know. I don't know. I don't know. I don't know. Next question. Yeah. So the value of potential gradient in the potentiometer experiment in balanced state is due to the value of potential gradient in a potentiometer experiment in balanced state is due to okay. So question talking about value of potential gradient in a potentiometer experiment in balanced state is due to at balance point you have to consider. Okay, so see what I'm asking here at balance state it balances only by the primary circuit. Okay, potential gradient we consider in potentiometer experiment only by the primary circuit. So I hope all of you know about all these concepts. So if you don't know, so please, okay, don't mind me. Okay, you don't know only. Okay, seriously, I'm seriously telling you, you don't know, you don't know. Next, we are moving for next questions. Yeah. So the sensitiveness of an emitter wire can be increased by. Again, this is very good questions. Please, okay, this is very good questions. I'm not going to explain it. Okay, so decreasing potential gradient on its wire. Okay, so if you decrease the potential gradient, so basically what will happen? By decreasing potential gradient, so you know, I hope you understood. So sensitiveness of potential can be increased by decreasing potential gradient. Okay, now moving on next questions. Yes. Again, this is questions. This is question in front of you. So cell of EMF, internal resistors are connected in the secondary gates, balanced by the length L of potentiometer wire. This is length of the potentiometer wire. If the resistance R is connected in parallel with the cell, then the new balancing length of the cell will be yes. A cell of this is a cell. We are using the cell of EMF E internal connected in secondary gates balanced against L of potentiometer. Okay. So balancing point is what? L. This is balancing point. If you understood, you need to focus here in this question. Balancing point is L. If resistance R is connected in parallel with the cell, then the new balancing point. So now what we are doing, our resistance R is connected in parallel with the cell. Parallelly. So we are connecting resistance in parallel. The question asking you new resistance. Again, if you know, you know, you don't know, you don't know. So your correct answer will be R divided by R plus R into L. R divided by R plus R into L. So you know, you know, you don't know, you don't know. Next questions we are going for potentiometer is an ideal instrument because answer is no current is drawn from the source of unknown EMF. No current is drawn. Very important point. Very good questions. Very important concept. Everything is good. Everything is good. Everything is good. Okay, accept me. Okay, so no current is drawn from the source of unknown EMF. I hope all of you understood the concept. You know, you know, you don't know, you don't know. So don't attempt. You don't know, don't attempt. Please don't attempt. It will demotivate you. It will demotivate you at all, at all. So potentiometer is an ideal instrument. No current is drawn. And next question we have on increasing the resistance of primary circuit of potentiometer, its potential gradient will. Haha. Yeah, this is a very good question again. So basically, what we are doing, we are increasing the temperature, so on increasing the potential, on increasing the resistance, on increasing the resistance of the primary circuit of potential gradient will decrease. Potential gradient will decrease. Next question we are moving for. The quantity that cannot be measured by potentiometer is resistance, EMF, and this. So inductance is the correct answer. If you know, you know. You don't know, you don't know. Next question is, if a value of potential gradient or a potentiometer varies decreased, then the new null point will be obtained. So what is basically what we are doing? Potential gradient, potential value decrease. So basically what we are playing here, value of potential gradient is decreased, Okay, then new null point will obtain. New null point will obtain. So what's the correct answer? What's the correct answer? So new null point will obtain. So lower length, higher length, same length, and a higher or lower length. Okay, so correct answer will be higher length. Okay. So basically what we are doing, we are potential gradient on potentiometer wire is decreased. So we are decreasing potential gradient on potentiometer wire. So if you are decreasing, so question is asking you length. About the length means about the null point will shift. Will shift means we need high length and all this. Okay. If you know, you know. You don't know, you don't know. Don't mind me. Okay. Next question we are moving for. Oh, this question is cell of negligible internal resistance connected to potentiometer. Basically, what we are doing, a cell of negligible internal resistance. No internal resistance is zero. Is connected to a potentiometer wire and potential gradient is followed. So connected to a potentiometer wire, and potential gradient is found. Potential gradient is found. Keeping the length as constant, keeping the length as constant. If the radius of potentiometer wire is increased, four times. So length is constant. See, take care of these questions. Very good questions. This is ranker questions. You know these questions, your rank is going to be boost at all. Okay. So see what I'm saying, keeping the length as constant and radius of potentiometer wire is increase. So basically radius, this is length. Okay. This is radius is going to increase. Okay. Four times. How many times? Four times of R. So then potential gradient will become. Okay, potential gradient will become. Again, it's very easy and very doable and very good question. Very good question. Very good question. What's answer? Constant. Potential gradient does not depend on area. Potential gradient does not depend on area. Potential gradient does not depend on area. Next questions. We are moving for next questions. Okay, next questions. Next question. Potentiometer is used to what? I don't know this question. I don't know this question. I don't know this question. Okay. The potentiometer can be used to measure EMF, no issue in it. Okay, to calibrate voltmeter, no issue in it. To determine the internal resistance. So many experiments we do. Okay, so in labs, if you know, you know. You don't know, you don't know. So we all of the above is the correct answer. Next question we are moving for. For the working potentiometer, the EMF of cell in the primary circuit E compared to that of cell in secondary circuit is. For the working of potentiometer, I'm talking about the working of potentiometer. I'm asking you to compare the EMF of cell in primary circuit and secondary circuit. So EMF in primary circuit will be what? What? E will be always greater than E1. Okay, secondary circuit. Okay, so EMF in primary circuit will be greater than, okay, EMF than secondary circuit. You know, you know, you don't know, you don't know, leave it. Okay, next question we are moving for. Balancing length of potentiometer L1, L2, and two cells of EMF are connected in the secondary circuits in series. Okay, first to help each other, next to oppose each other. So E1 by E1, E2 is equals to, again, this is easy question. This is experiment based question. If you do no experiment, you can do it easily, fastly. E1 and E2 are connected in the secondary circuit in series. First, we are connected in series. First, to help each other means in the same direction of current. Okay, and next to oppose each other. So E1 by E2. So in first case, okay, E1 value of this is, so two cells of EMF is E1 and E2. The question asking us what is the E1 by E2. So question is asking us what is E1 by E2. So this is this again. This is a good question. So what's correct answer? L1 plus L2 by L2 minus L1. L1 plus L2. Remember this result in your brain. If you know, you know. If you don't know, you don't know. Okay. So this is not L2 minus L1. This is not L2 minus L2. Okay. So basically, I'm talking about mode of L1 minus L2. Mode of L1 minus L2. Okay. So take care of all this concept in your brain. So now we are moving for next question. You know, you know, you don't know, you don't know. Don't mind me. Yeah. Next question we have, at the moment when the potentiometer is balanced. Is each question is current flows in the primary circuit. Okay. At the moment when potentiometer is balanced, current flows only in the primary circuit. Okay. Next question we are moving for, temperature coefficient of resistance alpha and resistivity are. So we are doing like this. So the resistivity rho of a potentiometer wire must be. So again, this is fact-based question. If you know, you know. Experimental-based question. If you know, you know. You don't know, you don't know. So don't mind me. So this. What's correct answer in front of us? Correct answer is low and high. So basically, what's temperature coefficient of resistance? Alpha should be what? Low. Alpha should be what? Low. And resistance should be what? High. 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 For what? Potentiometer wire. Potentiometer wire. Potentiometer wire. If you know, you know. You don't know, you don't know. Don't mind me. Yeah. So you can justify yourself by many means. Okay. There are so many ways people justify each other. Okay. If they you know what I mean, what I'm saying the same mean what you are thinking. Okay. Now next we are moving for next question. If the even for the cell in the private circuit interval, then without changing the cell in the second is and I say again this is a good question. So this will be the answer will be half C to double. Next question we are moving for sensitivity to potential device increase of length of the wire. So again this is good questions, easy questions. Anyone can do these questions. Increase with increase of length of the wire. The sensitivity of potentiometer increase with increase of the length of the wire. Next question we are moving with temperature. The potential gradient on the potentiometer wire V1 V2 with the ideal cell and a real cell, and a real cell of same EF in the primary circuit. Then, so the potential gradient on potentiometer wires are V1 and V2 with the ideal cell and real cell of same EF in the primary cell. Then V1 equals to V2. This. What is this? What is correct answer? So the ideal cell, real cell of same EF in the primary circuit. Okay. So answer will be V1 will be greater than V2. Okay, so potential gradient in the potentiometer wire are V1 and V2 with an ideal cell and a real cell of same EF in the primary circuit, then V1 is greater than V2. Now we are moving for next questions. I hope all of you understood the questions. Okay, the only increasing resistance of the primary circuit of potentiometer, its potential gradient will become. Ooh, yo. So basically, I'm talking about only increasing the resistance of primary circuit potentiometer, its potential gradient will what? What will become what? Less. Potential gradient will become what? Less. Hello, X will be. Okay, will become what? Less. Okay, on increasing resistance, potential gradient will become less. Less. If current in the primary circuit decreases, the balancing length is obtained. If the current in the primary circuit is decreased, then balancing length is obtained at. Okay, current is decreasing means higher length. See, basically think like this. If current is decreasing, so resistance will be what? Resistance will be what? Tell me. Tell me. Think like this. Okay. Resistance will be what? High. Can I say? Tell me. Next question. We have sensitivity of potential can be increased by this. So here answer is okay. So here see more than one options may be correct. Okay. So what is your answer? So your answer should be what? Okay. See what's happening here. The sensitivity of potentiometer can be increased by increasing the series resistance in the primary circuit. So basically increasing series resistance in the this basically resistance, we are increasing the resistance. Yes or no? Increasing the length or increasing the length. So now all of you understood by increasing the length, sensitivity of potentiometer can be increased. By increasing the length, sensitivity of potentiometer can be increased. I hope you know. You don't know, don't mind me. Okay, next question we have in a potentiometer experiment, the balancing point of length of cell is 1.5 volt in the secondary circuit is 440 centimeter. Resistance 5 ohm is connected between the terminals of the cell, then the balancing point of length is 400 centimeter. Again, it's a good question, doable questions in potentiometer experiment. The balancing length of a cell of EMF 1.5 volt in the secondary circuit is 440 centimeter. A resistance of 5 ohm is connected between the terminals of the cell. Then the balancing point is 400 centimeter. Then question is options I'm giving you in front of you. So options are we have the options of this. So what is answer? This. The correct answer will be A, B, and D. You can go through questions. You can do these questions. Doable questions. You can do it. Okay. Next question. We're moving for next question. We have match with one, match with two, match with one, match with two, match with one, match with two. This correct answer is basically I'm talking about potentiometer. Potentiometer is what? Potentiometer is what? For measuring internal resistance. For measuring internal resistance. Then what about meter base? Meter base is what? For measuring a specific resistance of the wire. Okay, meter base to measuring its resistance of the. Then what about ammeter? Ammeter is what? For measuring current. For measuring current. Then what about voltmeter? It is for measuring potential difference. Hello, excuse me. Can we move for next question? We are moving for next question, guys. So if you know, you know, you don't know, you don't know, don't mind me. When known point is obtained in the potentiometer, then the point, the current drawn from next question is okay, when known point is obtained from the potentiometer, the current drawn from. Okay, see, this question now I already did. So if you know, you know, you don't know, you don't know. So what's the answer? Only from main battery, only from main battery. This is very important question, doable questions, but people don't do because you know the reason. So there are so many ways. There are so many reasons in this world to not doing questions, not attending the question, not knowing the questions, not knowing the concept. There are so many ways. There are so many short questions. So people are taking shortcuts. That's why you know what I mean. You know what I mean. Yeah, yeah. Next question we have in comparing the EMF up to sense with the help of potentiometer at a balance point. The current flowing through the wire is taken. What's the answer? In comparing EMFs of two cells with the help of potentiometer, we are comparing the EMF two cells at a balance point. The current flowing through the wire is taken from. So at balance point, the current through the wire is taken from what? Okay, battery in the main circuit. Again, it's a good questions. Okay, so battery in the main circuit, battery in the main circuit, battery in the main circuit. Okay, battery in the main circuit. Next, we are moving for next question. We are moving for next question. The radius of potentiometer wire is double without changing its length. The value of potential gradient, I don't know. And trust me, I don't know. Does not change. Does not change. Does not change. Next questions we are moving on. Next question, the potentiometer of 10 wires. Okay, the balance point is obtained on the sixth wire. To shift the balance point to the eighth wire, we should, okay, this correct answer, increase the resistance in the primary circuit. Okay, so when we increase the resistance in the primary circuit, when we increase the resistance in the primary circuit, obviously the balance point will shift, okay, to the eighth wire. So again, this is good question, very good question. Doable. We can say moderate question. If you know, you know, you don't know, you don't know. If you don't know, so dance it, please. Okay, dance one time. Okay, dance and go for dance, and then come back and do the question again. Then only you can do. Otherwise, you are moving for next questions. Okay, so this is statement one. This is statement two. Statement one, the potential difference of a cell decreases if current is drawn from the cell. Okay, during this charging potential difference. Okay, okay. So I don't know this question. If you know, you know. I'm moving for next question. Yeah. The next question we have is to draw more current at low potential difference. Parallel connections of cell is preferred. This parallel comes I equals to N this. See, in parallel combination, current is N E by N E by N E by R equal to R in parallel connection. Okay, to draw more current. Okay, so I'm deleting these options. Okay, I'm deleting these options. So, okay, don't attempt this question. Yeah, to draw more current and low potential parallel connections of cell is prepared. Okay, to draw more current at low potential parallel connections. Yeah. So next we are moving for next one. This is correct. Okay, this is correct. Okay, this is correct. Okay. Sure. Then we will the next question. Yeah. When cells each of their resistance are arbitrarily connected in series, the total internal resistance of the cell may be zero. each of internal resistors are arbitrarily connected in series when cells. Okay, the internal resistance depends on the concentration of electrolytic use. What's the correct answer? What's the correct answer? What's the correct options are in front of us? Okay, in front of us. Statement one is wrong. Okay. So basically, when cells of internal resistors are arbitrarily connected in series, the total internal resistance of the cells may be zero. How it can be? How it can be? This is wrong. No issue in it. Okay, the internal resistance depends on the concentration of electrolyte use. Yes, correct. Okay. Now we are moving for next questions. You know, you don't know, you don't mind me. Yeah, next questions we have. The voltmeter is better than a potentiometer for measuring cell of EMF of a cell. Potentiometer draws no current while measuring EMF of a cell. So what's the answer? What's the answer? So voltmeter is better than potentiometer for measuring EMF of a cell. This is wrong. And potentiometer draws no current. Potentiometer draws no current while measuring the EMF of a cell. Okay. So now we are moving for next question. So please go attempt through this question. Go through this question. Next question we have assumed the current carrying a wire should be negatively charged. A current carrying wire should be negatively charged. The current in a wire is due to the flow of and this. So what is this? Current carrying wire should be negatively charged. What is the meaning of this? Okay, what is the meaning of this? The current in a wire is due to the flow. Okay, no issue. Okay, yeah. So this is correct. So no issue on it. Yeah. So I hope understood the concepts. You know, you know, you don't know, you don't know. Next question, we are moving for bending of a conducting wire affects electrical resistance. Okay, and resistance of a wire. What is your correct answer? So it's nonsense. It's totally nonsense. It's totally nonsense. But this is correct. Okay. So resistance of a wire depends on resistance of the material. You know, you know, you don't know, you don't know. So if you know, you know, you don't know, you don't know. So don't mind me. Yeah. Don't mind me. If you know, you know, you don't know, you don't know. Next, we are going for next questions. Okay, next question we have. In the middle race, copper wire is connected in the left gap and silicon is connected in the right gap. When the temperature of both wires increase, balancing point shifts to the right. See, again, I did so many times these questions. If you know this is copper, this is metal, and silicon, this is semiconductor. So temperature of both wires increase, their resistance will going to increase and their resistance is going to decrease. Going to decrease. Okay, then you can manipulate the thing, balance point shifts to the right, and temperature coefficient of copper is negative and that of silicon is positive. Temperature coefficient of copper is negative, and this gives this nonsense, nonsense, nonsense. What is correct answer? What is correct answer? So first is correct, second is wrong. Okay, first is correct, second is wrong. Okay, no issue yet. Next, we are moving for next question. So in a potentiometric potential, EMF of a primary cell is decreased and length of the wire is increased, its sensitivity increase. And sensitivity is more for low potential gradient. Okay, so what's your correct answer? So, okay, both is correct. Okay, both is correct. No issue it. When we are moving for next questions, in simple battery circuit, the potential point of lowest potential is positive terminals of the battery. The current flows from the higher potential to low potential in the balance of the closed circuit. This what's the correct answer? Okay, yeah. So second is correct. No issue in it. Okay, in a simple battery circuit, the potential point of lowest potential is positive. Nonsense. Nonsense. There is no sense means 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 nonsense. Next question. Yeah. So primary cells can be recharged, but secondary cells cannot be recharged. Chemical reactions involved in primary cells are irreversible and secondary cells are reversible. What's the correct answer? Primary cells cannot be recharged, can be recharged, but secondary cells. This is totally nonsense again. Primary sense irreversible and secondary sense are reversibles. Okay, so go through the options. You understand the concepts. Okay, very good questions. Okay, good questions in front of you. You know, you know, you don't know, you don't know. You know what's this? You know, you know, you know, and you don't know. The next question here. Current flows only when a source of potential difference is connected across a material which has excess of free charge carriers. What is the answer? Okay, source of potential difference cannot produce free charge carrier. It only directs the yeah. So correct answer is true. Okay, see here. Source of potential difference cannot produce three charge carriers. It only directs the three charge to move in a file. This is correct. Okay, only current flows only when source of potential difference is connected across a material. Okay, and which has excess of free charge. This is nonsense. This is nonsense. Flow only when current flows only when potential is connected across a material. Okay, across a material. Potential is correct. Okay, material. Yeah, material. Then we can go through it. No issue. It. Okay, then we can go through it. No issue. Okay, this is correct. Okay, yeah. So I hope you understood the concept. Understood the concept. Next, moving for next question. We have next question. We have next question we have. See, question is when a wire is stretched to double its length, okay, its resistivity, I don't know. Trust me, I don't know. Resistivity. Question talking about resistivity. Nonsense. The wire of resistance are spotted and identical cells and all the other kept side by side form a bundle effective resistance. It's a good question. It's a good question. It's a good question. It's a good question. To go through these questions, attempt this question, think on this question. This is a good question. Next, we'll move to next question. So when a wire is traced so that its thickness is half, its resistance would become 16 times. The division of resistance of potential across the limit of the flow below the zero. What's your answer? What's your answer? Go through this question again. This question again, very good question. This is first question, numerical questions. You can attempt this question. This is numerically. This is the correct answer. Okay, numerically you will get the answers. If you know the shortcut, you can do it. Otherwise, okay, leave it. And what can I say? Yeah. So now we are moving for next questions. We have is this VI graph for connected to different T1, T2, so on. And this T1 is greater. See, basically, how to think these questions, students. See, this is basically V equals to IR. Basically, see how to think this question. I'm explaining normally. V is what IR. So see, this is on y x-axis, okay? So this is right like this. I equals to 1 by R into B. 1 by R into B. Now see, this is x-axis and this is y-axis. I on y-axis. Basically, slope will give resistance. And then compare. Then compare. Okay, understood. I hope you understood. If you don't, please, okay, ignore these questions. Okay, yeah. If you don't, so ignore this question. If you understood, attempt this question. Yeah. So, sure, 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 sure. So we are going, so answer will be what? Statement 1 is wrong. So BI graph, so T1 is greater than T2. T1, this is wrong. And his system connector increases. Yeah, correct. Yeah. I hope you understood the concept. You know, you don't know. Don't mind me. Next question here. Effective resistance in series increases and parallel resistance decreases in series. This, see, you go through these questions. We know, you know, you don't know. Okay. So you should, okay, you should know all these questions. Okay, yeah. Next question we are moving for. On interchanging the position of cell in galvanic and balance meters to brace is connected P by Q are also remains unchanged. On interchanging the position of cell and galvanometer, I did this question so many times. Okay, interchanging of cell and galvanometer. An ammeter is connected in series in an electrical circuit and should have low resistance. It should have low resistance. It should have low resistance. It should have low resistance. What is the answer? What is your answer? What is your answer? If you know, you know. If you know, you know. You don't know, you don't know. So please go through this question again. This question is correct. So both are correct options. Both are correct options. This question is very good. Okay, very good, very good, very good. My favorite question. If you say this is my favorite questions, okay, if you know, you know. So correct answer is this. Next question we have. So in any junction of closed network, algebraic sum of various current is zero. Junction. I'm talking about in any junction. Junction. Okay. And current can be stored, cannot be stored. It must flow. So what's the answer? Again, you know, you know. So both are correct. Okay, no, you shouldn't. Okay. At junction, you can play with current. Okay. In the loop, you can play with voltage, energy, and the current cannot be stored. Yeah. Next questions we have. So this resistance between A and B is 3R. I don't know this question. See, again, this question is very good question. I'm giving you one hint. So see here, this point is A, this point is A. So this point is also A because this is connected to the wire. And if this point is B, so this point is again B. So see, this is R, this is R, AB, AB. So basically, this question is like this is very good, famous question for JEE. If you know, you know, you don't know, you don't know. So see, this is connected in parallel. If this is connected in parallel, so what is R equivalent? R by 3. So this is totally wrong. Okay. And the 3 is joined effectively in parallel. Yeah, this is correct. Okay. So so I don't know guys. I'm move on. Yeah. Estimated resistance of mercury at 4 kilo becomes 0. 0, 0, 0, 0, 0, 0. So yeah, both answers are correct. You know, you know, you don't know, you don't know. Some facts, if you keep in your brain, so resistance of mercury at 4 Kelvin becomes 0. And below 4 Kelvin, mercury is a superconductor. Next is we are moving on. Where current is drawn from a cell, the terminal potential difference is lesser than the EMF of cell. And when current is drawn from a cell, energy is dissipated due to internal resistance. What's your answer? What's your take? What's your take? Both are correct. No issue in it. If you know, you know, you don't know. So leave it. Next question. For ohmic devices, the resistance depends upon the potential difference across it and current flows in it. Okay. According to Ohm's law, I is proportional to B. So, sure answer. What's your answer? See, here all the students do mistakes here that for ohmic device, resistance depends upon the potential difference across it. Nonsense, blunder, nonsense. And this is correct notion. It. If you know, you know, you don't know, you don't know. If you know, you know, you don't know, you know, you know, you know, you don't know, you don't know. You know, you know, you don't know, you don't know. Yeah. Next question. Memory force on current. Once current is established in the superconducting ring, current continues to flow without any decay. See, superconducting ring. I'm talking about even without any applied voltage. Superconductors have zero resistivity. What's your take on these questions? Okay, the both is very correct. If you know, you know, you don't know, you don't know. Next question we are moving for. Thermistor resistance is independent of charge changes in temperature. Oxford's answer for this question. So, okay, thermistor resistance is independent of changes in temperature. No, it's okay. No, it will depend. Okay, so this is wrong. Nichrome has high resistivity. Nichrome has high resistivity. This is correct. Nichrome has high resistivity. High resistivity. High resistivity. Next, we are moving for next questions. Okay. As the temperature of a metal increases, the electrical resistance increases. Mostly metal obey Ohm's law. Most metals obey Ohm's law. Both are correct. Don't know, no, no. Okay, yeah. Semiconductors have negative temperature coefficient resistance. If the temperature of semiconductor increases, I don't know. I don't. Okay, temperature increase, its conductivity decreases. I don't know. I don't know. So basically, two is blunder. Basically, if the resistance, then it may be correct, but it's totally blunder, and this is correct. Okay. So if you know, you know. You don't know, you don't know. So we'll go with option number one. Again, these questions are very important for all examination point of view. If you are okay targeting for good ranks, then only. Yeah. Okay. So statement resistance of an ideal voltmeter is zero. The most ideal voltmeter is this. Resistance of an ideal voltmeter is zero. How it can be? How it can be? And most ideal voltmeter is 1 Okay. So we are moving for next question. We know you don't know. No. And there is some currents. Many are zero charge of a charge body quantized, quantized. Okay, so charge of a charged body is quantized, no issue in it, and already some this also correct issue, no issue in it. We can go with two options are no issue in it. Next question here. So terminal voltage of a cell is greater than EMF of a cell during the charging. Okay, during the charging. Okay, EMF of cell is always greater than its again. This is if you know, you know, you don't know, you know. See, second is basically a blunder, and first you know, you don't know, you know. Basically, question is talking about this charging, so this is correct. Okay, during charging, this is correct. Okay, so show. See, so during charge, this is correct. So we are going for next questions. Next question we have. So these questions we have is junction diodes transistors are ohmic resistors. For ohmic resistor, voltage current graph is a straight line passing through origin. So see, basically this is wrong. Basically, this is junction diode transistors are ohmic resistor, and this is correct. So no issue yet. Okay, so we're moving for next question. If you know, you know, you don't know, you don't know. Okay. Okay, we are moving for next question. The conductivity of an electrolyte is low compared to a metal at room temperature. The number density of free ions in electrolyte is much smaller compared to number density of free electrons in metals. Further, ions drift much more slowly, being heavier. Again, this is very edgy questions. Very edgy questions. You can do these questions. You can do this question. Both are correct. We are moving for next questions. Both are correct. We are moving for next questions. Whew. If solid conductors obey Ohm's law. Ohm's law is universal law. See, it's a blender. Actually, it's playing with you. I'm playing with you. So, and this is correct. Okay, this is correct. You know, you know, you know, you know, you don't know, you don't know, you don't know, you don't know, you know, you know. Yeah. So I'm going for next questions. Next question is for you. Next question is for you. Hey, what's happening? Yeah, no one is sure. What's? Yeah. Next question we have. The EMF of cell in secondary circuit must be less than EMF of cell in Balancing length cannot be more than a length. Balancing length cannot be more than length. Okay. So what's your take on this? Both are correct. Both are correct. Secondary circuit must be less. Must be less. Secondary circuit must be less. Must be less. Must be less. And balancing point cannot be more. Cannot be more than length of potentiometer one. Cannot be more than. Cannot be more than. So I'm moving for next questions. Yeah. Sure. Temperature increases, resistance of conductor increases, resistance. I don't know this one. I don't know this question. If you know, you know, you know, you know, you don't know, you don't know. Okay, next question. Yeah. So this is the question. Okay. So on charging, in charging a cell, the direction of current is drawn from positive to negative charging. I'm talking about charging. This, and the direction of current is always from higher from lower person. Direction of current is always from. So okay, so both is correct. No issue rate. Okay, sure.